Assalamu alaikum warahmatullahi wabarakatuh. And Sat Sri Akal, Namaste, and good afternoon to everyone who is joining me in this free for all mathematics classes. I have continued since last, I would say, pandemic started this math free coaching classes for grade 9 and 10. Today is my next session or lesson. As you can see on the screen on my board, today's topic is finding values of a linear equation. We are talking about linear equation. In my previous lessons, I explained how we can find out the equation of a linear graph and what was slope, how to find out the ratio, how to find out the equation of a line if we have 2 points uh, on the graph. So that makes very easy to find out the slope, and then we use the basic equation of y is equal to mx plus c, where m is the slope, and we know how to calculate the starting point c or the constant point. So if someone still like to understand that concept, they can review my last week lesson. But today's lesson is focusing on finding a value of a linear equation. So as you see on the screen, there are two methods to find out the values of a linear equation. The one is using a graph, and the second one is using the equation of the line. These are the two ways I'll be explaining how we are using these to find a value of a linear equation. As you see on the board, I have drawn two one graph lines or x-axis and y-axis quadrant and one table. I will explain you how I am going to utilize this information to explain the using of graph first, and then I'll explain how you can use the equation of the line to find the values of the linear relation. So in this, I have drawn this Celsius temperatures with 0, 25, 50, 75, 100, and 125. In Fahrenheit, I have used 50, 100, 150, 200, segment of 50, 50. The purpose of me selecting this Fahrenheit and Celsius temperature was, as explained in my this textbook, it will explain how we can find out a relationship. And people sometimes think, even when we convert online and we say, let's go and Google how we can convert, say, 50 degree of Celsius to Fahrenheit, and that gives us exact calculation. So how those formulas can be generated? Today, after going through this whole exercise, I am sure that you will understand this is how the mathematicians and the scientists sometimes derive their results and derive their equations, and that's the way they can easily find and confirm that these formulas or these equations or these relations are accurate, and they can prove from their number. Excuse me. So let me explain you. So now, when we are finding values of a linear equation or linear relation, we are trying to determine the value of a linear relation. Two of the easiest methods are creating a graph of the relation and using the equation of the relation to solve the value algebraically. So we can use algebra to calculate the values. So let's see the first I have right here, how we are going to use this to derive this result. So if you see on my left side of the graph, I have drawn this, which I will be using according to this table. On right hand side, I have been given some information where the Celsius temperature, when it's 0, we get 32 Fahrenheit. When it's 100, we get 212. When it's 25, we get 77. So the question mark is, what will be if the Celsius temperature is 32 degree, or what will be the Celsius temperature when the Fahrenheit is 100, and similarly for the 40, we are going to find out the value in Fahrenheit. So if you see this, the first graph I have shown, so if I use these numbers, then I can use the first method as I mentioned, using graph to find out my values. So let's see, the first value was 0 and 32. So 0, 32 means if x was 0, let's say this is called in simple way x value or y value. So this is my x-axis, that's my y-axis. So if there's 0 value on x, y is 32. So my 32 would be, because I'm drawing this approximately, so my 32 would be somewhere close to this number. So that would be my first number. The next number is 100 and 212. So let's see, 100 is right here and 212 will be somewhere close to this number. So that might be, if I draw and if I bring from this, so most probably that would be the number. The next number is 25 and 77. So 25 is right here and then 77 will be somewhere here. So it would be approximately something right here. So now if I draw a graph or if I draw a straight line passing through these, sorry. Now I would be able to use this graph value to find out the missing values. So this is the first way of finding a value in a relation or linear relation. So let's say this graph is asking me, or this table is asking me, what would be the value if the Celsius temperature is 32. So let's see. So if the Celsius temperature is 32, if I am using approximation, so let's say that could be right here. If I use this up, and then if I see right here, it might be somewhere above 100. So if you ask me, because I am not using exact graph, so it will be challenging, but practically I would recommend to use a graph paper that will give you almost accurate value. So I am going to copy the number given in this example. So the number given in example is for 32, it's about, in Fahrenheit, let me see, 89.6. So it's coming a little bit lower. So I might have drawn a little bit the other way. So this is why I'm not actually drafting. So this would be around that number. But this is exactly, so if you are asking for 75, you can go all the way this way and then find out what this number would be. And this is how you can find out the value of y or the Fahrenheit using the graph. So as I mentioned earlier, there are two ways you can find out the values of a linear relation. The first one is using graph. So I am currently using graph. So what I did, I actually plotted these numbers, 2, 3, whatever was given. So that gives me a pattern or line. And then the remaining missing numbers I can utilize and find out the exact coordinate, y coordinate or x coordinate from this line and find out the number. That might be a little bit not that much accurate, but if my graphs are accurate, my measurements are accurate, then this will give me almost an accurate number. The second method was using the equation of the line. So now, if I'm using an equation of line, you know in my previous lesson I explained, to find out an equation of a line, we need 2 points, 2 coordinates on that line. So in this particular case, we have 1, 2, 3, almost 3 numbers. So this is my first number, second number, and third number. So if I use any of these, I can create equation of a line using y is equal to mx plus c. Remember, in my previous lesson, we explained y is equal to mx plus c, where y I have y2 minus y1, where m I have x2 minus x1 plus c. So in this way, we can easily calculate these values and find out. So I'm going to just rub that. I need that space as well to explain. I'm sorry, sometimes kids play with these things, and then I get into this situation where I can use a proper. So I'm going to use that same equation I was explaining, y is equal to mxb pattern, and let's see how we are going to calculate. So now if we have 2 points, which we have already 3, and the y-intercept, we can find the missing value algebraically because the information gives us the equation of the line. As I mentioned in previous lesson, once you have 2 points which are actually lying on that line, we can easily find out the equation of that particular line. So let's find out the first rate of change. Remember the rate of change I was mentioning there, m. So to find out m, I need y2 minus y1, x2 minus x1. So let's say I'm using the value of this 212. So if I'm using one of this, and the next one I'm using, say 77 or 25. So let's see whichever number, or 125. I don't know how they are getting 125. Okay. On the graph, so I have rate of change coming up as 212 minus 77. So this would be my first y2 minus y1. Somebody likes to write down like this. We can write down, say, 100 and 212 is my first coordinate, and 25 and 77 is my second coordinate. So you see, this is my x1 y1 or x2 y2 or x1 y1, whichever way you like. And the next one I would have 100 minus 25. So that will give me a result of 135 over 75, which will be finally resulted into 9 by 5. If I calculate, if I cancel these numbers, my final answer would be 9 by 5. Because I can divide by 15. So if you divide by 15, 15 5s are, and 15 9s are this. So this is my now m. I got value of m now. From this m, and using any of these coordinates, I can easily find out the value or exact the equation. So now in this case, if I have to find out the value, and if I say that y is equal to mx, so means if I'm using this as y and this is my x, so in other words, I'm replacing y with f and replacing c with x. It's the same in algebraic. We can use y or x, but because we are talking about centigrade and Fahrenheit, so we are going to use the different kind of variables, and we change these variables to y or c. That can be possible because we're just replacing the value. So now I can write down f is equal to mc plus this constant value, which in our case we have 0. And now if you see f is equal to, our starting point we have, in this case is 32, sorry. So in this case we have 32 starting point, so we can write on 32. So m was 9 by 5 c plus 32. So what happened is, utilizing the mathematical results, we were able to find out an equation or a relationship between these numbers. So our final relationship came to this: f is equal to 9 over 5 by 9 by 5 c plus 32. So if you put these any values into this, we can easily find out the value of c or f, anything whatever is missing. So if we are given the value of c, we can insert into this and find out the value of f. If we are given the value of f, we can insert the value of f and calculate this equation algebraically, just like a simple algebra, and we'll find out the missing value. So now you can see that how we can find out the values of a linear relation. First one was by graph. As I mentioned, that once you draw the graph, then what are the missing values are, you can find out the exact, the other coordinate on that line, and you can find out that value. Or the other way is, if we have given at least 2 points, to find out a linear equation, we need minimum 2 points. So we have here 3, so we can use any of these. But I used the second and third one, and using the value, these values, I find out the ratio, which is m, or slope. We can call it slope as well in many algebraic calculation. They might call it ratio, they might call it slope, or they might just say a difference between two coordinates, y coordinates and x coordinate ratio. Anyway, it's the same thing. I calculate this value, final result was 9 by 5. And as I mentioned before, the value y is equal to mx plus c. In this, we have starting point is 32 because we start with 32 in Fahrenheit. So I have this starting point is 32. M, I find this ratio, and then we can say y is equal to 9 by 5 x plus 32, but because we are talking about Fahrenheit and Celsius temperature, so we just replace x and y with f and c. No big difference. The only difference is by putting f and c, it's much convenient for everyone to understand what it is. But another way, it's just a mathematical or algebraic relation. So I hope everybody was able to understand the two different ways how we can find out the values of a linear relation, how we generated this equation, how we can find out the missing value if we have 2 or 3 points and we get a pattern, and then we can find out the missing value. If you have any questions, feel free to contact me at 416-571-1163. You can join me every Sunday at 1 o'clock for mathematics free for all classes. And I'll be more than happy to help and assist my viewers, all students, or I know many of the parents also join and review these lessons and improve their knowledge, which in result help them in helping their kids. So you can share these videos with your family, friends, or anyone you know they can take benefit out of this. Until next Sunday, thank you very much once again, and have yourself a wonderful Sunday.